The Arduino little microcomputer is an amazing little gadget, and it can seem really complicated especially when you first get started. But let's break this down and try to make it simple. In my view of the thing, there's really only three categories of parts of the sketch code. Count them. 0, 1, 2. Well, that's kind of odd. I did it that way because the Arduino and C language tends to start with 0. For example, if you look at the pins on this Arduino, they start with 0. And when you have an array of things, the first one is called number 0 and then number 1. So I've just kind of followed that convention and said there's three things, 0, 1, and 2. All right, to learn this, we're gonna along the way we're gonna model a little demonstration emergency locator beacon. So here's what I've got here. We're gonna model this little device that's gonna have about 4 different little gadgets on it: an LED to flash our SOS, and we're gonna have a piezoelectric buzzer that's going to sound at the same time. We'll have a little adjuster so we can adjust the frequency if we want to change the tone, and we have a button that starts it off. So it doesn't just do this all the time. The device is active, but we activate it by pushing this button. So let's start off in a nutshell, looking at the different types of punctuation that's used for each of these three categories of things in the code. Okay, first off, comments. There's two ways to make comments. You can use a / and then follow it with comments, or put / and a whole bunch of lines of comments ended by */. And I'm going to include in this also blank lines and spaces. Now that can be within your comment. You can have extra blank lines and spaces, or even in the code is kind of I'm going to call that a kind of comment, because it's there not to affect how the code runs, but just to make the code more easy to read. All right, the second thing, or number one, is single statements. Most of the things you're going to write in the code are single statements. And the rule is every single statement is followed by a semicolon. And you can put 1 per line, or you can put 3 in a line like this with, each one followed by a semicolon. Or when you put things in a block, like in your loop or in your setup, you're going to have a curly Q bracket, and within there you're going to have a bunch of statements all followed by a semicolon. Now, a couple things to note. You might tend to think that the semicolon separates statements. It's really better to think of it as that it ends every statement. So it's a terminator, not a delimiter. So, because even the last one has a semicolon after it. Whether it's in curly brackets or in a list on a line, every statement has that semicolon at the end. All right, the third kind of thing is we elevate this a bit, and we take our statements and put them in the larger structures. So I'm going to call this category number 2 the basic punctuation of our structure and our control sequences. For example, I think you've probably seen you have it's actually a function in your Arduino called a setup and another one called a loop. And we'll talk a little later about what this void and these brackets mean. We'll get to that. There's also functions that you can write yourself. And the basic idea is that when you write them, all these statements are surrounded in a curly bracket. Okay, another structure, a conditional structure you use is you have called an if loop. So if this condition is true, we're going to do a bunch of statements within this block separated by curly brackets. Else, we can optionally do these other things. Okay, while is another form of loop in code. And notice the similarity. We have while this is true, do the stuff within the curly brackets. One more is a for loop. So do this stuff in the brackets. Whoops, I'm missing my end bracket here. Let me go back here. So I need to have a curly bracket right there at the end of that statement. So let's go back and slideshow from the current slide. Okay, so those are 4 examples of a structure and control. Notice they all use these curly brackets. And notice also the statements inside are going to end with the semicolon. But notice that the semicolon is not used after the curly bracket. So it's not as though everything ends with a semicolon. It's only single statements end with a semicolon. And then we get to a larger structures, loops, and functions that we define. We no longer put a semicolon outside of that structure. Another thing to point out here is when we have a condition, we say if this thing equals the value of true, or if A equals B, we don't say 1 equals. 2 equals is a comparison operator, and 1 equal means I'm going to assign something. So if I say A equals B with 1 equal sign, that means I'm taking the value of B and putting it in to the variable A. But the 2 equal signs means I'm comparing A and B. Are they equal to each other? All right, that's kind of it in a nutshell. You know, that might be all you need to know. But let's go look at each of these 3 things in more detail and come up with some common examples of each of how we use them. Okay, our first category is comments. There's really not a lot to say about comments, but they're more important than you might think. We've already mentioned there's 2 ways to use comments. The more important thing is what do you put in a comment? So what you want to do is you want to state the function. What does this sketch do? Who wrote it, and maybe what date you wrote it. These are all things someone might want to look at later and help them. It's helpful to understand what the sketch does and who wrote it. Maybe explain some of the potentially confusing parts in the sketch. And I've also said including extra blank lines and indenting extra spaces, all are part of making the sketch more clearly readable. So let's give an example here of, I've actually done this before. This is the code that we're going to write together to control this little emergency locator beacon device. But here, just for fun, here's the exact same code with all the comments and a lot of the spaces and extra lines taken out. I think you could see it's a lot easier to see what's going on here. Like here's where I flash the S, here's where I flash an O, here's where I flash another S. Here's where I'm going to adjust the tone. You know, this might look complicated, but at least you can see what's going on. But if you look at this thing, well, you might think, well, it takes less space. Look at this, it's a very short list, where this is a long scrolling list of things. Wouldn't this be preferable? Well, even a good coder, a good programmer, is going to look at this and have a hard time understanding what's here. Another interesting thing is, okay, both of these will compile properly. Both of these will run identically the same. But notice here at the bottom where it says how much space is taken up. Both sketches use the exact same number of bytes in the program memory. So there's absolutely no savings by leaving comments out. So they help make the sketch a lot readable, and they don't waste space. So you can see some of the things I've done here. Up at the top, I define kind of what the sketch does. This is going to be our demonstration Emergency Locator Beacon. It's going to signal SOS in Morse code using LED and a tone. And it's going to be activated when we push the button. And it's going to go forever, actually, until you push the Arduino reset button. So if I upload this to this Arduino, okay, we've uploaded it in here. It took 3082 bytes of memory. I push this button and it starts to run. And if I said, oh, I don't want it to do that, I'll just push the reset button and it starts the thing over. So basically the code is going to wait until I push that button. Now the button might not be a button. It might be some kind of sensor. So for example, some of these electronic beacons are made for like a sailboat. So if this falls in the water, in the salt water in the middle of the ocean, it might sense the salt water and turn on automatically. So the device is kind of already on, but we need to activate, starting to transmit that we need help. So that's about it for sketches, or comments and sketches. It might be useful. I'm going to keep coming back to this, looking at the reference material. You can't remember all this stuff. So if I look in the Arduino, so if I go just to arduino.cc and the home page for Arduino, if you click on documentation reference, comes to this reference part. And comments are a little hard to find. They're kind of down here called syntax. So here's the block comment and here's a single comment. Another way to find it, if you didn't know where that was, is if you search up here for comments, and you're going to find more things than you want. But here, for example, in a reference article is this type of comments or this type of comments. So I click on that and it takes me to a page that describes more about comments. And there's really not a lot to say about it. It shows you two ways of use this. You can use the whole line with / at the beginning, or if you have a particular line you think people might not know what that does, you can, at the end of the line, you can put / and then explain what that line does at the end. So the important thing here is to know how to find the documentation reference material. And notice that it's defined roughly the same as what I'm describing. I'm actually combining kind of functions and variables as statements, and then the structure for all these different types of loops, I'm calling that a separate thing because the punctuation is different. Functions and variables have the same kind of punctuation as a statement, so I'm describing them together. All right, let's start taking a deeper dive. Let's go and start coding for this device. So let's bring up our IDE environment. I'm going to say File, New. And I can get these other ones out of my way. I'm done with these ones that I showed you earlier. Okay, well, let's see, that one, get that out of my way. So you make this a little bigger. So I've got a simple empty, it has nothing but this thing called setup and a loop. And we'll talk more about what even that punctuation means. But one of the things programmers like to do is define what's called pseudo code. So, often, a pencil and paper is the best way to sketch out what's the order we want to do things, and where do we want to branch and do something different on a certain condition, things like that. So let's kind of write a pseudo code here for the sketch for this emergency locator beacon. So up near the top, for example, that's where we're gonna define what our. Actually, before that, we need to define our comment. So it's slash slash. This is a demonstration. Emergency Locator Beacon. And I can further define how it's going to work, and put the name of the author in here, and maybe the date, and I can make extra lines as I want. So another thing I'm going to define up here now at the top. Let's not do it yet, but say here's where we're going to put our. Going to define the input and output pins. So we're going to use 4 different devices on different pins. So we're going to put that there. And then let's say I'm going to declare my variables. I'm going to put that there. So I'm not even writing the code yet. I'm just kind of blocking it out. Okay, in the setup, I'm going to have to do a thing here to define the pin mode for digital output. Don't actually have to do this for analog. So two of these devices are digital. The LED is a digital output, and the buttons can be a digital input. So we're going to have to define those at some point. And we're going to do that. You're going to define the pins up here. Then within the setup, we have to define the pin mode. So I'll make that. I'm going to maybe say input and output, because there's going to be both. So down in the loop. Let's get rid of this comment, because we know that just kind of gets in our way here. Down in the loop, again, we know that's going to repeat indefinitely. But what we're going to do first, we're going to say, actually we can put this up in the setup. We can say I'm going to wait for the activation button. Otherwise, so we're not going to start. So we'll leave that in the setup. Down in the loop part, we're going to eventually we're going to adjust the frequency. So we'll be looking at this potentiometer and use that to check that first. See what value we set. That might be like a factory setting, for example, as to adjust the tone the device makes. And then we're going to loop here, we're going to flash SOS on the LED and the tone. And then at the end we're going to say let's delay a little bit before we restart. Start the loop. So there's kind of like a little pseudocode we've already started documenting it. So that's an example of how I might use comments. Even before I've written anything, there's nothing to say you can't write pseudocode with a paper and pencil, but you can also write it right there in the code with comments. Okay, for single statements, we're going to define kind of 3 common types. There's the variables, and there's 2 things you do with the variables. You declare the variable. That's like putting the plate out for dinner. There's nothing on it yet. The plate is going to hold the food, but we decide, are we going to have a dinner with a plate or a soup bowl? Which kind of variable do we put? So how do we set the table? A glass is for drinking. A soup bowl is for soup. A little plate is for salad, maybe. And then we're going to assign values using maybe math functions and things like that. So declaring it just says put the plate on the table. Assign says put the food on the plate. All right, functions. Now I'm talking here about when we use a function, because when we define a function, it's going to be just a little bit different. So we've kind of talked about some of the format. Every function is going to end with a semicolon, and we'll talk about then the specifics. Remember, there's this thing called the brackets at the end of a function. What does that mean? So how we use a function we're going to talk about. And then there's some other things that are like Arduino specific. All the things above here might really be the same for any C language program. But some things are very unique to the Arduino for the digital and the analog and the LED lights and things, and how do we print values on our screen. So those are going to be Arduino specific. All right, let's jump in and look at variables. So the first is when we put the plate on the table, we define what type of plate is it. Is it a bowl or a plate or a glass or a fork? All these things are different things we use to set the table. And common types then are integer, and it uses the letters int, floating, which are things with a decimal point, and fractions of decimals. So integers are just counting numbers, 1, 2, 3, 4. Floating is 1.234. Boolean are variables that are either true or false. Sometimes they're useful. You don't necessarily have to use a Boolean. You could just use an integer and set it to 0 or 1, but it's common coding practice to use a Boolean variable if you're only going to use it to be one thing or the other. There's character variables, like storing the characters A, B, C, D, and there's other kinds, but these are the common variables you're going to use. Okay, when you declare a variable, you declare a type, then you give it a name. And the important thing is that names are case sensitive. You can spell it any way you want, pretty much, but you got to use it the exact same way every time, or the compiler will give you an error. And typical coding convention is to use what they call camel case. Have it all lowercase, except when you have multiple words. Take the second and third words, so on, and use an uppercase letter so you can make it more readable. Another thing that can be a little confusing about variables is they have what's called a scope. Now that means, where did you define it? So if I define it at the very top of the program, it's what's called global, and you can use it everywhere. So that's probably what I do most of the time, because I write such simple things. But you're writing a very complicated program, you might want to use a local variable. So for example, within a function you write, if you declare a variable there, another function won't know it, and maybe higher up in your program it won't know it. It's only defined within the function. So here's some examples. If I say dash length, when we flash SOS, we're going to have a length of time for a dot and a dash. So I'll declare an integer dash length to declare that variable I'm going to use. All the different pins I'm going to use. So for example, the LED pin, I might have it on number 11 or 12. I think I got actually an 11 now. But for example, I might put it on pin number 12. Okay, and then when I assign values, so here's where I might declare it, but I might say, okay, let's assign that the dash length equals dot length times 3. This is actually a Morse code thing, that the length of a dash is typically wants to be 3 times longer than the length of a dot. That's just kind of a convention for Morse code. So rather than entering a separate number, if I say dash length equals dot length times 3, if I change dot length, dash length automatically changes. So again, just looking at variables, if we go into the reference material for variables, there's many more types of variables, many more types than we've defined, but the common ones are integer, floating, character, byte, Boolean that I mentioned. There's other different types of variables. Won't get into them right now, but that you won't remember it. You want that reference material to be your friend. Okay, here's statements that use functions. Now, I'm not talking about defining the function now, just using a function. Because typically using a function is just a single statement. So, for example, the delay function, we're going to delay something for 1,000 milliseconds. So that function just performs that action. It doesn't return any value. I do. I send it a value of 1,000 to tell how long to wait. But it doesn't return a value to say, okay, I'm done, or what did I do? But other functions return a value. For example, the square root function. If I take the area and take the square root of the area, that gives me like the length of a square side. So to get the return value, I assign length equal to the square root of the area. So the thing here, these brackets, the parentheses type brackets, are used to send values to the function. Okay, another type of single statements, these are the Arduino specific things of pins, for example. So there's actually kind of like 3 places you might have to do something about a pin you're going to use for a certain function. So before the setup, at the top of the code, I might declare an integer to say, okay, this is my LED pin. So LED pin is the name that contains the value 12. Okay, then in setup, I have to kind of tell the Arduino that to prepare it to use a digital input or output. So I say pin mode, and the pin number, now I should have said LED pin here to put that value 12 in, but maybe there's another value of pin someplace else. And then mode. So the mode is typically input or output. There's also a thing here called input pull-up. So when things like a button are input devices, you can use the button to set the pin to a high voltage or a low voltage, and whatever voltage it's not connected to when the button is not pushed, to kind of keep it from floating to stray signals, we say input pull up. So in this case, I'm going to use the button to apply 0 volts to that pin. But just to make sure the pin knows that the button is not pushed, I'll use this internal thing called a pull-up resistor, which pulls the value up to the high value until I push the button, just to make sure it doesn't float halfway between the two. This is just hardware stuff, you know. It's just the way the Arduino is. Okay, then within the loop, I can say, so input equals read the value of the button pin. So that's going to be like high or low. And if I write something to like the LED, which is an output, I would have said pin mode LED is an output up here. So I do a digital write to that LED pin, and I set it to high or low. So digital things are one value or the other. In this case, high or low. And again, you're going to want to look, particularly for this hardware stuff, look in the reference material under functions. So if I go to functions, so here's for functions for digital input output and analog input output. Okay, so another kind of fun thing about the Arduino is if you want to make it make sound, which we're going to do in this little device here, there's a function called tone, and you tell it which pin am I talking about, and presumably I'll have defined a variable called tone pin instead of value equal, in this case I'm going to put that on pin number 5. So for tone, you don't apply a high or low voltage. It actually is, putting in a square wave at high and low. It's oscillating it back and forth. And I need to know what's the frequency I want. How fast do I want that to happen? And for how long do I want it to happen? Another way to do it is just say tone pin, and frequency, and just start that pin making that tone forever until I say no tone on that tone pin. So there's two ways to use a tone. And again, you could, in the functions, it's going to define, let's see, I got to find where in the world is, here's tone. They call it advanced input output. So tone, so it shows me the two ways I defined. I just showed you tone and pin and frequency, or tone, pin, frequency, and duration. And then there's other notes and caveats about how that works. So remember, the reference material is going to be your friend. All right, let's jump back in to our sketch here, and let's define these variables that we're going to use for these devices. And let's set up the pin modes, and let's put some of these flashing things in here. So here's this blank sketch. Before I go too far, I probably ought to save this and give it a name. So let's say File, Save As. Let's see, I better bring this over here, and let's call this Demo ELB. And I'll save that. So now it's called Demo ELB. Probably want to save it before we get too far along here. So in our input-output pins, I'm going to say, let's define an integer variable, and let's say my tone pin is going to be equal to 5. So if I look at this device here, here's my pencil to point. This piezoelectric is connected to button number, or pin number 5, and then the other pin is set to the negative rail. So it just connects between the pin and negative. So when this thing flashes the square wave, it's going to make this thing beep. Oh, one other thing I should note, for this kind of thing, for tone, it has to be one of these ones that has a little squiggle after it, because those are the ones that allow what's called pulse width modulation. So for anything like analog output, we use the pins that have the squiggle on them. Okay, let's go back here into our code. So that's going to be our tone pin. I'm going to integer for the LED pin. And let's see, what do I have that on? Let's see, actually it looks like I have that right now set on pin number 10. And let's say, let's put these all in, even though I'm not going to use them all just yet. Input button pin, that's going to be on, I have that on number 2. You remember that 0 and 1 here, 0 and 1 are kind of reserved for serial input and output. So when you actually upload your code to the Arduino, it actually uses 0 and 1, and these little lights here, transmit and receive, will flash when there's activity on these two pins. Sometimes you can get away with using these, but not if you're going to, if you're going to connect other devices. If you're going to use serial output at the same time, you can't quite get away with using things there. So we kind of avoid using those two pins. All right, let's declare some variables. Let's go back here. So in my variables, I'm going to say, those pins are variables also, but these are variables that are going to contain a value I'm going to use for other things. Let's say tone, whoops, I'm going to spell that. And I can't actually use the word tone because tone is the name of the function. So I need to say something like tone frequency. And maybe just for now, let's say that's equal to 250 hertz, say. And let's define another integer for dot length. And I'm going to set that equal to 300 milliseconds. And then I'm going to say integer dash length. I can say that. Now I can either like just say define it and don't put anything on the plate, or I can declare it and assign it at the same time. So integer dash length equals dot length times 3. And remember, these all have to end with a semicolon. And I'm going to have one more eventually, is maybe my adjust pin. And now this is a little funny. It's going to be on A0. I say that's funny because how can an integer be with an A? So these analog pins down here are labeled A0 through A5. So there's 6 of them. Count them, 0 to 5. But in our code, A0 is kind of known by the Arduino to be what's called an alias for the number 14. So these pins go 0 to 13, and there's no pin 14, but actually this pin here, A0, really means pin 14. That's a little piece of trivia for you. So that's going to be A0. Let's see, what other adjust pin. Actually, I want to put, that's one of my pins. I want to put that up here just to kind of organize that a little better. So I got the tone frequency dot length dash length. Another thing I'm going to need is at the end of transmitting, we're going to want to wait a certain time. So let's put maybe call it wait length. And I can put a value right here. So there's our define our input output pins and declare variables we want to use. I don't need that many spaces. Maybe I just want to put one extra line. But you can put a blank line like this with nothing on it. You don't have to put slash to say it's a comment. Just extra lines, extra spaces don't affect how the code works. So wait for the activation button. I'm not going to do that just yet. Let's just leave that alone. So in void setup, let's see, down here I say I'm going to define the pin mode. So here's where I say pin mode. And just to be consistent, I'm going to space this over 2 like this. And pin mode is going to be for the LED pin. I'm going to want that to be, so the LED is going to be an output. Now you define this in all uppercase, O-U-T-P-U-T, output. And close the parenthesis and then put a semicolon. It feels like double punctuation, but this is kind of part of, this has to match that. Here's a little clue. If you select or click on any bracket, it shows you the mating bracket. So, or you can click near it, it highlights the other one. And let's just do that. We'll worry about the button a little bit later. I think I'm going to just put that much. So down in the loop, later we're going to put our potentiometer with analog input, but maybe just say, for now, let's say tone freq equals 300. You know I defined that up ahead here. Maybe I don't, just so it won't be confusing, let's not define it here. Let's just put a blank plate up here, and down here we'll set the value. So now we're gonna flash the LED, and eventually the tone. We'll worry about the tone, and I guess we could put that here. Let's see. So the trick I'm going to do is I'm going to say digital write, and I'm going to set that camel case. Now, just to be consistent, I like to indent that the same amount. So I'm going to digital write to LED pin, and I'm going to put it to a value of high. That's not right. You got to spell it right. Notice it lit up in that blue color when I spelled it right, so it recognized that it's a special thing. If I spelled it wrong or didn't finish, so once I spell it, so there's a lot of intelligence going on in this little IDE for recognizing some of these known reserved names. And notice how when I hit the return, it moved right under the D for the digital. It kind of honored my indentation. So let's put in here. So now I'm going to delay for the dot length. I should probably say this is the S part, so we're flashing out the S. So we're going to put in dot length semicolon. Now after that length, we've got to turn the thing back off. So here's a shortcut. If I copy both of these, I type Control C, and I'm going to click here and type Control V. So also I have to do, if I double click on the word high, it selects it, and I set that to low, and I'm gonna delay here for the dot length. Is that right? Yeah, I think that's the kind of, so I turn it on for dot length and off for dot length, and then I'm going to do that 3 times. So if I select this and I type Control C to copy, click down below. Now I wonder if I leave an extra space just so we can see. So there's the, and come down here and do another space. So that should be the sequence for the S, which in Morse code is like dot dot dot. Now let's put an extra delay, because if we start right in, people don't know it's another letter, so we have to put another delay, and the convention is to put in a dash length. I'm going to leave a little extra space here just so I see that's something else. And then at the end of the thing, we haven't put the other letters in. We're going to delay for that wait length. Now I haven't finished yet, but there's no reason I can't check and see what I've done so far is going to work. So I can hit compile here. Voila! That like never happens, that I made no mistakes. So let's upload this into the Arduino. And remember, we only have the S so far, the dot dot dot. And it waits and does a dot, starts over dot dot dot. Okay? So I'm going to unplug this to stop that from annoying me. So there's the S. Now I'm going to have an O, and then I'm going to have another S, right? Well, the other S is going to be the same as this one, so let's select everything here that's in the S, and you can either type Control-C or I can right-click and say Copy, and click after the S, and I can right-click and say Paste. So there's the S. Now the O is going to be, similar, but I got different lengths. So let's select just this much of this and paste that in here. And O, there's going to be dash length, and the delay is still dot length. So there's the first dash. Let's hit an extra line space, another space. So there should be my O. And now I need a little bit of a delay space, like I did at the end of the O. I need an extra little delay so you can tell the difference between one letter and the other. I'm going to be fussy and I'm going to line these up. And I think that's all okay. So we haven't put our tone in yet, but we have the S's. Let me show you another thing like I do sometimes. There's two ways to do this. On any kind of a function like this, remember I said it's between these two curly brackets. Sometimes I'll put my cursor here and enter a carriage return so that these two curly brackets line up this way. It just makes it clearer to me. That's a convention. Some people like to put it there. All the sample programs come with the Arduino have the first curly bracket up after the name, and then the other one on the left side. But I just find if I put it there, it makes it easier to check that I've got everything included. It's very easy, especially when you start getting if loops and while loops, to have the brackets not match. So if I select this bracket, I can come down here and see that this bracket matches that one. So let's check this, verify we don't have any mistakes. And then I have to plug this in. So let's see if this much of it works. And we'll send that to our Arduino. And it should now be flashing Morse code. Okay, so that looks like that works. So let's put in our tone also. We've talked about tone. So come back here to, so when I turn the pin high, I'm going to put in here also tone on the tone pin, and it's going to be I want to play a frequency of tone freak. Can you see what I'm doing there? Okay. And I'm gonna let that be a duration of dot length, so I don't have to turn it off myself, and then a semicolon. Now I have to do this. We should have done this before I copied this, but so it's going to go here, here, and here. So that's for the S. So before I go on, let's double check, see if this is going to work. Let's compile this. You don't have to wait till you're all done to check it. So that compiled okay. So let's upload that to the Arduino. and then the dashes and the second S don't make the tone because we didn't put that yet. But at least we've double checked that we did it right. So let me take this first S, because with all the tones in there, and come down here and copy that. Rather than do this manually, I'm going to take this second S and make it like the first one. And then for the O, we're going to have to take this statement for the tone and come back here in the O, put that right in here. And this time I'm going to play the tone for dash length. So let's copy that and put that in the other two places. Okay, let's double check again, see if we did it right. Compiles okay. We plug this in. Well, that's flashing what it did before. It remembers that code. So I need to upload the new and improved version of the code. And then it should wait a while till it starts over and starts that sequence again. Okay. Let's unplug that so I don't have to listen to that all the time. So now would probably be a good time to save this sketch as I've got it. Okay, so somewhat we've done that much of our emergency locator beacon. Let's go look at now analog input and output. Remember, so analog input is going to use these other pins here. So I've got a wire from pin A0 that goes to the middle of the potentiometer, and then the potentiometer, one side here, let me make that a little bigger just to show you how that works. One side is connected to plus, one side is connected to minus, and then the middle is connected to A0. So when we change this knob, the voltage changes between the high voltage and the low voltage. So if I leave that somewhere in the middle. So let's go back here. And just go back and check our so we already defined the adjust pin on A0. And I don't need to define a pin mode for analog. Just kind of weird because analog is always in. Digital can be input or output. And again, remember this. Remember, the reference material is going to be your friend. So here's what I'm going to put. I'm going to input this analog value, and then I'm going to do an analog write down in the loop. So what I'm doing here in this, let me indent that just for clarity, and I'm going to say input, or listen, no, we're going to get our tone frequency now, and instead of setting it, we're going to read it. So I'm going to delete that one. So our tone frequency is going to equal analog read of, and it's going to be our, which pin do we say that was? That's going to be our adjust pin. So analog read is going to read adjust pin, which is A0, and it's going to get a value between 0 and 1023. That's just kind of the way the analog pins work. So if it's 5 volts, it's all the way up here. And that's kind of convenient because that's kind of the frequency ranges we want. So I'll say tone frequency equals 0, equals what I read directly from the adjust pin. Now remember, I put a semicolon here. I don't need a semicolon out here because this is just comments. This is really the end of the statement. So let's compile this, make sure this is going to work. Okay, well that's what we're doing here. I'm a page ahead of us, so this is exactly what we just did. And now another thing too, in terms of debugging, sometimes it's useful to use print, and there's a thing in Arduino for a serial print. Now, what I did here to develop this piece of code, make sure this works. Sometimes we want to check not the entire code, but just a piece of it. So I've got this one called analog read, where I have basically just that part of the code. I do an adjust pin, and I do down here I'm going to do the tone frequency equals analog read of the adjust pin. But now I'm going to print it out so I can see, is this working okay? One other thing you need to do for serial print, in the setup you need to put serial.begin, and the typical value is 9600. And where that comes from, if we open up this serial monitor, okay, and it says it's not available because this isn't plugged in. So let's upload this code to the Arduino. And now if I look at the serial monitor, I have it printing out what the frequency is. So if I change the adjustment on this knob, the frequency goes up, or I turn it down and it goes down. And at a certain point, if you get too low, it doesn't make any tone at all. So that's what you could kind of play with by looking at this. Well, another fun thing you can do with this exact same statement where I'm sending it to serial print, there's also a serial plotter. This is kind of fun because I can make a graph as I change this potentiometer. So this can be really useful, like if you want to check a sensor and see what it's doing. Is it behaving properly, or is it a temperature sensor and you want to see how the temperature varies during the day? You can use this graph function. So I think that's kind of fun. So that's what I did here. So I used the serial print, and what I actually did was, there's two forms of the serial print. There's serial print, and it does not add a new line. And so I print frequency equals with a space, and then I did a serial print ln, which prints followed by a new line, and I printed the tone frequency. So in this thing here, so I did a serial print with frequency equals, and then I did a serial print line with tone frequency. So the result is, now if I want to look at it, I got to plug it back in. Is where it's like frequency equal and gives me the number. And it just keeps, you see how fast it changes. And that's even with a little delay. So that's about it for serial print. It's very useful for debugging. So like somewhere in your code, you don't know if it's working right, you can print out what is the value at that point. So I showed you how you make a plot. And the tip is that this is really useful to say, test parts of your code. So notice I didn't test this entire thing. I just put that little piece of code in a separate sketch so I could test it out. So here's another thing we can do. Notice this code is kind of sloppy. It's kind of long, right? Well, what if I wrote a function for dot and dash? Because I do that over and over again. So let's take this first bit of the S here. That's what it takes to flash that first bit of a dot. So let me copy that, and I'm going to come down here at the very end. I'm going to hit a return, and I'm going to say, here's where that word void comes, void dot, and I'll put in bracket. Now what the word void means, remember when we used the functions, some of them returned a value and some did not. So the functions that don't return the values, you say void because it doesn't return anything. That's all that means. That's the same void you have up here, like void setup and void loop. So we're writing a dot and it's void because it's not going to return anything. I'm going to be using global variables I've already defined. So in the dot, now I got to remember, I'm writing a function, so I put my my curly bracket, and at the end I put another curly bracket. So if I select either bracket, it highlights the other one. Whoops, I'm in the way of my picture there. So you can see that those dots match. So that's going to be our dot function. And now let's define another function down here is going to be dash. And we're going to need our curly bracket. Notice it automatically put in the other curly bracket. So let's come in here where the O is. This is the code to transmit a dash. So between those curly brackets, so notice that by indenting, it makes it clear. Here's the two brackets, and then here's the code between the two brackets. It makes it really clear to read. So although this is not a comment, I'm kind of including that in the same category of things just to make the sketch more readable. Now we've got a lot of stuff we don't need anymore here. So for the letter O, let's get rid of this all except for that extra space. And all I need to say is dot semicolon. Now because this is so short, let's just put them all on the same line to show you that we can. Right? And that's not actually the right place. That's my O here, or my S. I deleted the wrong part. So for the S, I'll make a dot, 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 and then delay a dash length. O is actually going to be, this is where I got the wrong one, dash, dash, dash. I'll copy that, paste that on each one of these. And then the S is going to be like this one. I have two of those, I don't need that one. So this, you can see this code is a lot clearer. Here's the S, the O, and the S. Dot, 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 dash, 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 dot, dot, dot. So that's just by using these two functions. Let me get rid of this extra. Let's not gloat. Let's see if we did it right so far. Wow, I'm batting pretty good today. Haven't made many mistakes. So let's plug this in, and it should do the same thing. And it's beeping from the old code that's in there. So we upload it. good? So you can see the use of functions. Just by writing these simple little functions, we really shortened the code, because this was stuff we used so many times. So another type of control structure is an if condition. So if some condition is true, you're going to do the statements in this curly bracket, and then this is optional. You can say else, do the things here. So if it's cold outside, turn the heat on. Else, if it's not cold on, maybe you want to do check again to see if it's cold enough or hot enough to turn the air conditioning on. So here's an example. Remember in that code where I showed you the frequency? When it got that too low, it just didn't make any noise. So let's put this condition here where we adjust the frequency. Let's not let the tone get less than 20 hertz. So I say if tone freq is less than or equal to 20, and I'm going to put my curly bracket, and between the curly brackets we're going to say tone freq equals 20. So let's see what we've done here. Then notice I've indented it. I have the if statement at this level and my curly brackets at that level, and then I indented two more. So the code can start indenting at multiple levels. It just makes it easier to read. So if this frequency is less than 20, set it. Now what did I forget? Well, here's one I forgot. This is a statement in here, and even though there's only one, I need to put the semicolon at the end. So let's check, see if I missed anything else. That looks good. So when we plug this in, now remember I got to transmit it, upload it first. Now this time if I turn the knob all the way down, it won't go to 0. But notice it only reads this analog input at the start of the loop. So it's not an immediate adjustment, it just checks it that once. But if it's a factory adjustment, that's fine, and that works okay. So I can set that to any value, and then it prevents me from putting at such a low value that it doesn't work. Alright, here's another one we can do. Remember we said we wanted to make this so it doesn't start right away. So in the setup, let's use a while loop to say while the button is high, it hasn't been pushed yet, let's do, in this case, actually nothing. So let's go back to our code here, and up into the setup, I'm going to say actually, I meant to put this should be down in the setup. So I'm going to put this down here. I'm going to shut this off for now. So I'm going to say while, and how do we put it? So while what? Let's space this over for consistency. While, and it's going to be what I come back with a digital read of the button pin. Now did we set up, we didn't set our pin mode for our button pin. Pin mode for the button pin is going to be an input, but I'm going to use the form of pull-up. So if the digital read of button pin, and here's where I use two equal signs, so if that equals the high value, so while that's true, we're going to do this stuff in here, and we're going to keep doing it. It's not just like an if statement where we do it once. A while is a loop that says keep doing it. So right in here we're actually do nothing until button pushed, right? So if that looks good, and I don't even have any statements, so I don't need any semicolons. Let's verify this, see if I did that right. Looks good. Now let's plug this back in and upload this. So now the device just sits here and does nothing. So it's actually running. It's waiting for some emergency condition to happen. Maybe it's waiting for it to say, don't throw this one in the salt water, but maybe it's meant to be a floating beacon, and when it senses salt water, it turns on. Or maybe it's a device where if someone falls down, it senses the force of falling and turns on. In this case, we're going to push the button, and that should start it working. Now the button doesn't turn it off. The way to turn it off is to reset the device with this button here. So now it's back in the state where it's on, but waiting for that button to be pushed. Oh, one other kind of loop. Let me show you what I'm doing here. Another kind of loop is a for loops, to repeat something for a specific number of times. Now it's kind of silly, but we could do that here. Like notice we're doing something 3 times. So we could put here for. Now the format of a for loop is I have a counter variable and I set it to a starting value, and then what's the maximum value going to be? So as long as it's less than or equal to this max value, it's going to keep doing this. And then I have count equals count plus 1. Now count plus plus is a little shortcut here. It really says count equals count plus 1. So you can use this anywhere in your code you want to increment a number by 1. That's such a common thing in coding that they have this shortcut, count plus plus. And then in the curly brackets, that's the stuff we're going to do that many times. So for, now we haven't declared a variable yet, so let's declare one right here. Let's say we have an integer, and let's just say it's the value I, and it's going to equal, let's start at 1. And I always forget this delimiter here is a semicolon, like it's a statement, but it's really not. So as long as I is less than or equal to 3, we're going to repeat this, and then we're going to say count equals count plus 1. I'll not use the shortcut here. So what are we going to do in there? So we're going to put our curly bracket. So between the curly brackets, we're just going to do this dot. And I don't need these other two, but I do need that one because I need a delay after I've done the 3. So this should repeat 3 times. Now we could do the same for those others, but let's see if we have this right. Aha! So I've got something wrong. It says count was not declared. Here's where I made my mistake. I'm using I as the counter, not count. So this should say I equals I plus 1. So the variable we're using is I. Now I will only be known within this. So I could use I in here, but I can't use I somewhere else because that's called a local variable. Only within this loop is it known. So let's try that again. So you can see why I like to do code a little bit at a time and then test to see how it's working. But we had our pseudo code kind of marked out where we're going to put the code. So let's upload this. Now it's still in the state where it's active, but when I push this button, if I have this loop done properly, it's going to flash 3 times. Okay, so that doesn't really save us a lot by using a for loop there, but it just shows you how the for loop works. Well, that's it. You know, we've covered a lot of ground about different, within 3 categories. If you think of just 3 categories, you know, we've covered a lot of it. We got our comments, we got statements, and then we have larger control structures or larger structures of loops and things. So there are some things we have not covered, but the beauty is they're going to follow the same pattern. Statements end with a semicolon, and functions, when you define them, like we defined a dot and dash, it's code within these brackets or a loop. You loop on the things between the bracket. That's going to be common between all of these. We've got more types of functions, like random numbers and things. And we've got libraries for other structures we can add. We have other types of variables, but it follows these same patterns. So if you learn to look in the reference material, you can find this, and if you understand what we've covered, you can do the same thing. Here's one I'll just highlight. If you define an array, which is a list of variables, or a variable that is a list, you do the same thing. You declare and assign, values in this array. So here's the format. It's going to be an integer array, and its name is my pins. It's going to be like 6 values. And I use curly brackets to say, okay, these are the pins I'm setting into this array. So notice that we have more punctuation. Like for an array, you access each individual element with a square bracket and put a number. And when we define the list ahead of time, we use these curly brackets, but it's still a statement, and it still ends with a semicolon. So it's really not that different, although it uses some of this other punctuation in another way. Well, really, that's it. So just remember, this reference material is your friend, and it's organized largely the same way that we've done things here. So if you go to, documentation, reference, there's functions, variables, and then there's these structures. And they say comments, they've put comments down here under syntax. So I've defined it as 3 things. Comments, variables, and functions kind of together are statements, and then the structure is how we build statements into larger structures. So set a bookmark, or just it's easy to remember. It's just Arduino collective common, whatever CC stands for. Let me make that a little smaller. And in the middle of the top is documentation reference, and there's a lot of good material here that describes how each thing works. All right, good luck with it. That's coding in a nutshell. Have fun.